This is your video number 2 for the 1.2.2 notes. We're talking about the alternate interior angles theorem, which says if two parallel lines are intersected by a transversal, then the alternate interior angles are congruent. Okay, so let's look at the alternate interior angles. Interior in between the two lines, alternate side of the transversal, and adjacent to the alternate parallel line, if you will. So example would be angle 3 and angle 6. The other example would be angle 4 and angle 5. So sometimes you can think of this as a Z, if you will. That's one way of doing it. And we can do the other way. I'm not going to do it because it looks like a bad symbol from Hitler days, so we're not going to do that. But the idea is alternate interior angles, you can do the Z. So now, we know those are congruent. So what will it look like on a test? You'll have something like this. You'll have this is 120 degrees, and this is 2x plus, let's say, 20. So they'll say, oh, find the value of x. And you'll go, okay, 2x plus 20 equals 120. Why can you write the equation that way? Alternate interior angles theorem. That will be your justification. So then we solve the equation, subtract 20 from both sides, and we get 2x equals 100. You divide both sides by 2, and you get x equals 50. That would be your solution. Now, we have the converse of this theorem as well, which is the alternate interior angles converse theorem, which is if the alternate interior angles are congruent, then the two lines intersected by a transversal are parallel. So in this example, you'd have that angle 4 is 75 degrees and angle 5 is 75 degrees. So then, since we have that situation where the alternate interior angles are congruent, then we can say, oh, line W and line X must be parallel. So we'd have line W is parallel to line X. Now because of the alternate interior angles converse theorem.